Hi, in this video I was going to go through the examples from the week 4B poll that were in the first section. So to start off, what we're doing here is we are categorizing what is occurring in each of these different types of extractions. Most of the extractions are actually more than one, not all, but most. There are three main questions I'm trying to answer. What are the dimensions being subset during each extraction? What type of vector is being used to do the extraction? And I'm just clarifying, dollar sign's a little bit weird. I'm not sure how to classify the name of the column when you use the dollar sign. And then finally, what class of object is returned? Well, this first one is a little bit harder. But this first one is extracting the second column of iris first. So this is the first extraction that occurs. That produces a numeric vector. The reason why it's a vector and not a data frame is because it's a single column. Since the data frame can really only have one column, a data frame can really only have one type of data inside a single column. It ends up just simplifying it, because it's safe to do so, into a vector. Had this been multiple columns, that is not how that would have operated. But because it is, this by itself outputs a vector. And one of the things we know about a vector is that it's got one dimension. Since it has one dimension, we will need to use a single argument in the square bracket tool. And if we tried to use an additional argument, we would get an error message saying incorrect number of dimensions. Well, that's because all of this actually resolves to a single logical vector. And that's because the second extraction that occurs is this third column. Again, simplifying to a single vector because the contents of a column have to be a single type. It then compares it to the number 6, producing a series of trues and falses. That is now a logical vector being passed as the only argument in this third and final extraction, which makes a subset of what was originally over on this left side. That's the idea. Next, to check off things, this had a one-dimensional extraction in it. This had a two-dimensional based upon subsetting the column. Two-dimensional based upon subsetting the column. This returned a numeric vector. This returned a numeric vector. This returned a logical vector. And then finally, the actual output was a numeric vector. So lots of conversions and coercions and analyses all happening at once, and something that's really not that atypical. Taking a column and extracting values from that column based on a different column, or even the same column. It's very common. It's kind of a weird way to write it, especially for Iris, which does have column names, which I feel make the code much more readable. This next question, we use a numeric vector to extract the first two rows from Iris that will also return all of the columns, and that's what this blank I didn't actually need to have a space here. I just included it so it's a little bit easier to see. But not having anything next to that comma means it's going to extract all of the columns. So still a two-dimensional extraction, but only subsetting the rows. This one is different. Because this returned multiple columns, it's retained as a data frame because R doesn't consider it like always safe to simplify a data frame into some sort of single type object. And it certainly shouldn't have. This did have multiple types of data. You could not have simplified this into a meaningful matrix or vector. You would have had to lose some information. Q2 is, hi Cat. This is Riker, Tail. He really likes when I record things. Yeah, all right, come here. You get to look at the camera because of what you've done. Yeah, you're good. Ow, ow. Oh, jeez. He's fine. Anyways, this next one is doing something very similar, but it's added a value to the column side. So here we are subsetting the columns down to a single column, which will actually mean this returns now a vector. So you can see we've extracted those two values. This was a single extraction though, and definitely occurring on 2 dimensions as it used both rows and columns. Like I said before, this used rows, which means it had to treat it as a 2-dimensional object. So this also used 2 dimensions. Here is an example of a 1-dimensional. So if we just kind of ignore this $sign sepal length, here I have the output of that first extraction. It's a long numeric vector. Then I am using a numeric vector to subset that, but since it's a vector, I have to use a 1-dimensional tool. So in other words, there's no comma here. If I put a comma, I get an error message saying there's too many dimensions. It needs to be a vector. So this is a 1-dimensional style of extraction. So this next one is basically very, very similar to question 2, except instead of using a numeric vector within the column section, it's using the name of that column, which is fine. That just means that we're utilizing a character vector that references the names of those elements versus a numeric vector which references the index positions. I always just say index positions because index confuses people. It's almost redundant to say index positions, but I'm a teacher, so my goal is more to teach these concepts. This is the same thing, but this is just a length 2 character vector. So this will basically have the exact same output, except because multiple columns are now being extracted, just like in, well, I guess we haven't had that yet. Just like in this one, this will retain being a data frame because it's not safe to try and simplify this. And again, it shouldn't have. Those are 2 different types of data. You couldn't meaningfully simplify it to a single type of data. The next one, I mean, you could meaningfully, but not with the full nuance. The properties of a factor would be lost. The properties of a numeric vector would be lost as you converted them to a character. In this situation, I utilize some math, or well, some coding, I guess, to generate a bunch of numeric values. Oops, I forgot to catch my closing parentheses there. But then I immediately compare it to the number 3, producing a logical vector where only the first 2 values are true. That's being used in the row column, so I'm sending the row extraction to with a logical vector. Here I'm using a character vector. Nice, easy 2-dimensional analysis. Same thing, but this time I did the columns as well, showing in columns, number of columns, resolving to only a logical vector being used in a 2-dimensional extraction, and returning a data frame. Question 8 is using only 1-dimensional extraction methods. This one is opening Iris as if it is a list, because it is stored as a list, even if its class is data frame. So opening that up, I can see that it has output a vector type object, which means I have to use a vector like 1-dimensional extraction method. And so that's me pulling out the first and the 100th value. Question 9, so the percent or modulo, and I can pull up the help page for this. It doesn't give me a lot of information on it. It's not great. It does give me a few examples down at the bottom. It shows like how this is a periodic effect. Oh yeah, there you go. It gives you a little bit of details deep in there. It's a little bit hard to understand though. What it does is it divides and returns the remainder. So this will be each of the values, 1 through the number of rows, so 150. It will then divide those values by 20. So 1 divided by 20, the remainder is 1. 19 divided by 20, the remainder is 19, but 20 divided by 20, the remainder is 0. 21 is 1 again, and the cycle repeats. It then uses that math to output a logical vector by comparing the output to the number 1, as long as I get the parentheses right. As we can see, there's a little bit of a pattern to the true, and that's because every 20 values, it's producing a true. So at 1, 21, 41, 61, and so on. Finally, these were just fancy numbers. So in the end, this was a logical vector on the row side, a numeric vector on the column side, although they had negative positions, which actually remove those positions from the return data. That leaves us with the 4th column, the 5th column, and the 1st, 21st, 41st, and so forth rows. Really handy tool. Comes in handy more than you would think, Modulo. I always thought it was kind of silly that someone taught it to me, but so I took like this one like introductory seminar once. It was like a 3-hour class, and that was my first introduction to R. But honestly, I have used that one a lot, and I don't know when I would have found it otherwise. And someone had suggested it to me through a solution. Fun tool. Next one is not in your poll. I will talk through it though. You're here, why not? And it's not raining for a second. Oh my gosh, it is really raining in the distance though. So let me finish. This is an object that's built into R that allows you to visualize the distances between various cities in the US. I believe these are in kilometers, but I'm not sure. The original matrix is not actually a matrix. It's a distance object, which has its own properties and prints off a lot like a matrix, except it's triangular. However, I want to use it as a matrix, so I'm just going to coerce it to a matrix rather than have to deal with like distance object specific tools. I could always go backwards and convert it back to a distance object if I really needed to. This is pretty typical for me. I like working in base R because I'm really, really good at base R, and most things can be made to work in base R. And then I just kind of work back, and it makes me learning new tools a lot faster, which is why my class kind of emphasizes that. So here I've created an object that contains the matrices. Here I'm manually stitching together the cities that I want to extract from that. Here I am pulling out the row names from that matrix and then saying which of those values are in this city's desired object. So for each value, is Atlanta in that object? False. Is Chicago in that object? True. Is Denver in that object? False, and so on. I repeat that for the column names. Interestingly enough, a distance matrix, because of how it's structured, ends up being a square, and so it's a square that is sorted the same way. So this actually wasn't necessary, but just in case, I figured I would show this process, because I would use this same process to do other analyses as well. So anyways, if I run this, that creates a logical object. Here's the column logic. They're the same because it was a square matrix that had the same order to the values. And finally, I do some subsetting based on those logical vectors. If I really wanted to make sure this worked correctly, I should probably put some which statements around there, just because that makes any missing data work out. Again, though, I knew what I was working with, and because of how that data was structured, I don't really have to worry about some of this. So it is a bit redundant, for the record. Anyways, that works. So I've subset my matrix. Anyways, that's it. I hope that helped. Let me know if you need anything else. I think I'll make a separate video going through the rest of the poll questions.